Okay, so here's the golf ball. Okay, we're going to start at 0. If the distance of the ball is 0 meters from where the person's starting, X represents the horizontal distance traveled by the ball, okay? This is the distance in meters that the ball travels, and what does Y represent? Y represents the height that the ball travels in meters, and we know that it's going to be represented by a parabola. Okay, the equation is Y equals negative X squared, so is it going to open up or down? Down. Down. So it's going to look something like this, right? I'm going to erase that. But think about it. You're hitting the ball, it's going up in the air, and then it has to come down. So I want you to graph it exactly. We're going to start with a distance of 0. So it's 0 meters away from the starting point. 1, 2, 3, 4, 5. So these are our X values. So you're going to take that number and you're going to plug it into the equation and solve for Y. Okay, so start by doing. It starts at 0, 0. And think about this for a second. The equation is Y equals negative X squared plus 5X. What's C? Plus 0. C is 0, right? So we know automatically by looking at that, it has to start at 0. 0, 0. Okay, so once we've filled in the table, we can plot it on a graph and it will look. So to find the axis of symmetry, we're finding the midpoint of the X intercepts. In this case, it is an X-intercept, but a parabola might not always go through the X-axis. So it's the midpoint of an X-coordinate that has the same Y value. Does that make sense? I'll tell you why. Pretend this was your parabola. If I find 2 points that have the same Y value, then I know that the point in between that would be the axis of symmetry, right? Because it has to go halfway between any 2 points that have the same Y value. So they're at the same level. Think of it like that. So it doesn't have to be an intercept. Does not always just have to be an intercept, but it's the midpoint of any X coordinate that has the same Y value. So for example, look here at your graph. 1 and 4 and 4 and 4. Those have the same Y value, right? I'll go back to the graph. So the vertex is located at 2.5, 6.25. And this was not the graph, this was just an example. And the maximum value is Y equals, you have to put Y equals 6.25. That's the maximum Y value. And we didn't answer the axis of symmetry. What was the axis of symmetry? 2.5. You have to write X equals for the axis of symmetry, okay? And you have to write Y equals for the maximum value, and your vertex has to be a coordinate. I just put in Desmos. What are some things that you can tell me about the graph that you noticed? And I already told you one of them. What was the first thing I told you? That the graph has a y-intercept of? 0. It has a y-intercept of 0, 0, right? But that's also an x-intercept, right? That point intercepts both the x and the y-axis. Is there another x-intercept? Did you notice if it hit the x-axis at any other point? Where? It also hit the x-axis at 5, 0. That was another x-intercept. Think about it. It's a ball. The x-axis represents the ground, right? The ball starts on the ground, goes up in the air, and it comes back down to the ground. Was there anything else you noticed about the ball? It went up in the air. This was the highest point that the ball reached, right? This was the maximum. This is our y-axis. This is the maximum y value. We're going to figure out what that number is. It's a decimal. You can't read it from your graph. We're going to actually calculate it. But we know that if a parabola opens down, this is important. Look here. When a parabola opens down, it will have a maximum y value. It can't go further than this point, right? That's the highest point it can go. Think about it logically. It opens down, it has a maximum point. If the parabola opens up, let's say this is my graph, it will have a minimum y value. We're going to talk about this later in the chapter, but it will always have a maximum point and a minimum y value. It can't go lower than a certain point on the y, for your y value, right? The y coordinate can't go lower than that. Okay, does that make sense? Okay, so we're talking about some things here. We're talking about the x-intercepts, the maximum value. There's one other thing that we're going to learn today, and there's an imaginary line that goes through the parabola, okay, because we talked about a parabola is symmetrical, which means that this side of the parabola is exactly the same as the other side. It's symmetrical. Everyone knows what symmetrical means? So this is referred to as the axis of symmetry. And we're going to find the coordinate of the axis of symmetry. Sorry, the equation. Sorry. We're going to find the equation of the axis of symmetry. And think about it. The axis of symmetry passes through which axis? X or Y? Look at my line. I'm drawing an axis of symmetry. Does it go through the y-axis or does it go through the x-axis? It goes through the x-axis. So the axis of symmetry has an equation that says x equals something. Where would that imaginary line pass through the x-axis? Think back to what you learned last chapter, and you're going to tell me, how would you calculate that? You have two x-intercepts, close, and you have a point in the middle of them. Yes, midpoint. Okay, so we're going to calculate the midpoint. That's it. So 1 and 4 is here, and 4 and 4 is here. Would you agree that this point here is on the axis of symmetry? The halfway point between this coordinate and this coordinate is also on the axis of symmetry. The halfway point between this coordinate and this coordinate is also on the axis of symmetry. How about this one? The halfway point between these two coordinates is also on the axis of symmetry. You're picking any two coordinates that have the same y value, and you're finding the midpoint. Okay? So let's do this one. We're finding the midpoint of those x coordinates. So this was 1, 4, and this was 4, 4, right? We're trying to figure out what's halfway between 1 and 4. So how do I find a midpoint? So the midpoint would be, we're adding up our x values. 1 plus 4 equal divided by 2. What's 1 plus 4? 5 divided by 2. So the x is equal to, that's it. That's the axis of symmetry. You're done. That's it. That's the axis of symmetry. Let's check. I just want you to see how this works. Pick any other x coordinate that has the same y value. Was there anything else that had the same y value? 2, 6. What was it? Sorry? 2, 6 here. And 3, 6 here. Yep, those have the same x coordinate. You're trying to find your axis of symmetry. You're trying to find out what is the x value for the axis of symmetry, because the axis of symmetry will go through the x axis, right? Oh, sorry, 2, 6, 3, 6. Okay, so we're going to add up the x coordinates. 2 plus 3 divided by 2. Again, what do we get? 2.5. The axis of symmetry is 2.5. That's telling us if we were to graph the axis of symmetry, we know that we would start at 2.5 and we would draw a line straight up. Does that make sense? That's all you need to know for the axis of symmetry. Now, think about this for a second. Does the axis of symmetry go through a point on the graph? Look here. Does it hit a point on the parabola? Yes, it did. What point did it hit? The maximum value of the parabola. Does anyone know what that point is referred to as? It's called the vertex, okay? So, okay, so we found our axis of symmetry is 2.5. This is our axis of symmetry, x equals 2.5. And we know that it has to pass through the point which has the maximum y value, which is also referred to as the vertex. The vertex is the point where the parabola changes from increasing to decreasing. So it's the point where it changes direction. This is the point where the parabola changes direction, right? That's the vertex. Well, we now know one coordinate of the vertex. The vertex is located at 2.5, right? Something. Do we know the y value? It's a decimal. Can you tell from the graph where it is? I can't even tell in this graph. What do you think it's located at 2.5, 6 point something, right? How can we figure out exactly, here's a clue, we're given the equation of the parabola, we know the x value of the parabola, how can we find the y value? How can we figure out where the vertex is if we know the x value of the vertex? What are we going to do? Plug it into the equation. That's how we're going to find the vertex. Which will also give us what? The y value gives us the highest point, the maximum value, because the maximum value is located at the vertex. It can't go past the vertex, right? So y equals negative, we're going to replace x with 2.5 squared plus 5 times 2.5. Please make sure you do not apply the negative until you've done the square. This first, look, 2.5 squared. The negative is outside of the bracket. The negative is not part of A, remember? The negative is outside of A. So it's y equals negative. What's 2.5 times 2.5? Y equals negative. 2.5 times 2.5 is 6.25 plus, what's 5 times 2.5? 12.5. So I can rewrite this as y equals negative 6.25 plus 12.5. What is it? Yep. Positive 6.25. Does that look about right? Okay. So the vertex is located at 2.5, 6.25. So the vertex actually tells you the axis of symmetry and the maximum value of the parabola, right? It tells you two things. That's it. The question said, find the